Thank you for coming today. My name is Chen. I'm a developer advocate at Google, working on the Android project, so I'm happy to see that all of you are here today. And I'm here to talk about a couple of things. So I want to do a couple things. I want to run through some background in terms of giving you all, as developers, an idea about why Google and the Open Handset Alliance thinks that mobile is such an important market. And then we'll talk about what is Android from a technical level. I've got about 45 minutes to go through that, so I won't get to everything, but I'm hoping that in Q&A you guys can ask some good questions. And then the last thing is just catching you all up on some news. As you may or may not know, we've been running the Android Developer Challenge, as well as releasing SDKs, and so I want to make sure that you all know where we are today. So let's get started. So, oops, I gotta figure out how to use this clicker. So, one of the things that we always talk about when we talk about mobile is just how big of an opportunity it is. So, to give you all an idea of what that looks like, I want to show you this graph. And if you look up there in orange, that's the graph for worldwide PC-based internet users. So, as of 2007, we had about 1.1 billion internet users worldwide from PCs. By comparison, if you look up here, the blue line is for mobile phone users. And you can see that the line is, there's about 3 times as many, over 3 billion mobile phone users worldwide, and about 1 billion handsets sold every year. So from that perspective, the mobile market, especially as 3G and even 4G networks start to roll out, you can understand that access to data services and these sorts of things makes mobile more and more important for not just Google, of course, but for everyone involved with internet-based services. So with that, I think the way that Google approached Android was from the thought process of a software vendor, and Google, Google really found that current mobile platforms are a difficult thing to deal with because they're so fragmented. So we end up developing different versions of our applications over and over again for various devices and various platforms, and even sometimes, specifically for one device or versus another. And of course, a company like Google can afford to do that investment to bring our applications and services to end users, but not everyone can. And so, Google got together with 33 other companies to form the Open Handset Alliance in order to build a single common platform for mobile devices so that both end users and developers and also the existing mobile industry could benefit in a variety of different ways. And the comparison point that I like to make here is, as you probably all heard in the keynote, Google really views the web as a platform. And as an open platform, we've seen that it's been tremendously successful. And there's been lots of innovation because it's been an open platform, and mobile hasn't really been that way. So we're hoping that with Android, we can provide that common open platform to drive innovation. So I mentioned 33 other companies. Those companies that are working together in the Open Handset Alliance consist of 5 different groups. So first, of course, are the mobile operators. And then there are handset manufacturers, such as HTC, who is here in Taiwan. Software companies, and these are companies that provide software that go into the platform. There's also semiconductor companies. They make the chips, of course, that power the radios and the app processors in mobile devices. And, of course, commercialization companies. These are companies that help operators and manufacturers build and bring devices to market. So that's just a glimpse of the companies in the Open Handset Alliance that we're working with to build out Android. So that's a quick bit of background. What I want to spend the bulk of my time with you doing is talking about what is Android, and talking about it from a technical level. So where I thought I'd start would be from the classic system stack diagram. So we'll start with this, and this is at the very bottom. Android consists of the Linux kernel. So we build on top of the Linux kernel. It provides Android with a couple of different things. First is a well-known driver model. There's also memory management, process management, a security model. And these are all things that are well known and used in other places. So we're building on top of that. And you can see here in the stack, a lot of what we highlighted there is the fact that the Linux kernel provides Android what amounts to a hardware abstraction layer. It's a way for us to abstract away from the specific hardware that's on the device. So that's the Linux kernel. Next in the stack are the system libraries. So these are libraries that are written in C, C++, and written in native code. They come bundled in the platform. You'll see things like SQLite, LibKit, FreeType, and SSL. These are all well-known, well-used open source projects that we've integrated into the platform. So for application developers and device manufacturers, they benefit from having this integration done already. So we get these pieces of technology. On the far left, you'll see Surface Manager, a box that represents OpenGL-ES, which is our implementation of OpenGL, and then SGL, which is our custom 2D primitives drawing library. All those things are related to the graphics pipeline, and I think one unique thing about the aspect of the Android platform is that we're able to do 2D and 3D drawing to the screen at the same time. And then there's also the media framework. So this is contributed by Packet Video, and it's providing a common set of media codecs, so things to do audio, video, and still image encoding and decoding. So building on top of that is the Android runtime. And Ben Chen, who's going to be speaking after me, will speak more about the Dalvik virtual machines and specific technical details as to why we developed that. But at a high level, for all of you as application developers, what you'll be doing is writing your applications using the Java programming language. We have tools that convert the .class files that you'll generate and convert them into Dalvik bytecode. So Dalvik is a custom virtual machine. It does not run, say, Java bytecode, but what it does provide is a way for us to let you as app developers write your applications in Java, which is a language that I think many application developers know. And also lets us provide core libraries that are familiar to all of you. The core libraries that are there are most of what you would expect in Java 2 Standard Edition. So if you've ever done any development using that particular platform, you'll find the standard core libraries to be very similar. So on top of all of this is the app framework, and this is where the majority of your applications will interact with, or this is what the majority of your applications will interact with. The app framework provides not only constructs for creating your application, but also a series of system services and managers for providing brokering access to things like hardware on the device. For example, things like location. So if the device had GPS, or we were doing cell ID to determine location of the device. Through those particular system services, your application will be able to get access to that information. Likewise, with things like the notification manager, we have a standard way for your applications to show notification to the end user, even if your application isn't necessarily running. And then on top of that, and last, but certainly not least, I think, and this is what I think is really most important, are the applications themselves. Up there, I think we have home, contacts, the phone app, and browser. But those are just some of the apps that come bundled with the platform. And they're there because we want manufacturers and operators to be able to take the standard image if they want and be able to deploy it to a device. But by no means are those applications the only ones that can be on Android. For all of you who are third-party app developers, you'll be able to develop your applications. They have the same access and the same level of access to the same APIs on the system. So there are no such thing as privileged APIs or hidden APIs. And so you get the same level of access as even as the home screen. And I'll get into more about what you'll be able to do from the application later in the day. So that's a very brief overview from a systems level of what Android looks like. What I want to spend some time talking about is what does an Android application look like from a component standpoint? What does that consist of? And what do you put together as an application developer to write your app? So there's really four major building blocks in an Android application. There are activities, intent receivers, services, and content providers. And those are the four major components that you can use to put together your application. What I'm going to focus on today really are activities, because they are the representation of the UI or some sort of screen that your application interacts with, and is probably of most interest to all of you. So just before I get into talking in some detail, I'm going to define some terms. So in Android, an activity is, think of an activity as a molecule or a discrete chunk of functionality. It's something that the end user can do, like something specifically they can do. So think of it as like within your, if you're writing a mail application, it could be reading a mail or browsing the inbox, or one particular screen that you want to show to your users. Tasks are collections of these activities. So, and I'll get into more about what that really means in a bit. Also, when I say process, I mean process. A process in the Android framework maps to a standard Linux process. And then an APK is simply a file that contains all of the code and other resources that you bundle together with your application. Think of it as just the package that we use to distribute your application. So here's a brief or a high-level look at the anatomy of an application. On the outside, you can see everything is contained within an APK package. And within that, the various components that I described might run in a process. And then there's the various components broken out there. And this is just kind of a representative example. If you don't want to have content providers or intent receivers, you don't necessarily have to have them. I just wanted to show kind of what this would look like. So at a high level, think of an APK as basically a glorified zip file, really. The .dex files that you generate when you're developing, as well as things like a metadata manifest file, and then the resources that you're bundling, so things like graphics or sounds, music, all get packaged up into this APK package. And then inside that APK package, or for every APK package, there's a unique process. Every application that gets installed on the device has one process that's associated with it, or has a user ID associated with it. And by default, every application, every APK starts or has one process running. But as you can see on the right, if you want to, you can split out your service, which is a long-running background task, into a separate process. And there are various reasons why you might want to do that. And that's why that example on the right is up on the screen. Another thing to note about processes from the process level is that by default, every process has one thread. But because Android is a fully multitasking, multi-threaded platform, your application can start background threads if you want to do this work in the background. Because for one thing, the main thread is where all events get executed. So if we're passing events from the framework back to your application, you need to update the UI through that main thread. And if you're blocking on doing some work, that will make your application seem unresponsive to the user. Next is tasks. So tasks are really more of a concept than any sort of concrete class in the API. So you won't be implementing or extending a task class. Tasks, like I mentioned earlier, are a group of related activities. Activities that you can, that the end user can launch in succession. So you might be in the mail client, launch a second activity within that application to view a specific message. And then inside that message, there's actually a URL. And so if the end user clicks on that URL, what happens is that separate process and the activity in the separate process from the browser process that started out, for example. So, and really why there's a concept in terms of tasks is that for every task or thing that the end user is doing, there's a unique history stack that gets built up. So if we have a history in terms of UI screens that we're showing, that stack of UI screens is associated to that specific task. And from your standpoint as developers, your application is really contained within your APK and that code that you've developed. But because you're able to interact with other components on the system, integrate with them, to the end user, all of this looks seamless because it's just new screens that come up. So to most end users, a task is really what looks like a traditional application on say, a desktop operating system. And last but not least, of course, are activities. Like I mentioned earlier, they are something that your end user can do, and they're typically associated with having some sort of UI. So you'll be extending a class called activity from the APIs or from the framework. And like I mentioned earlier, they run only in this process of the APK that installed them. So there's never a case where your activity might start in a different process. And they're optional. And in terms of having a UI, that's actually optional. So if your activity is something where you only need to do something in the background very quickly, your activity could simply execute without actually showing a UI. So that's a bit about the specific components that you might be putting together as an application developer. What I want to show next is actually some of the tools that are available to you as developers. So the first is the Android emulator. This is a QEMU-based ARM emulator. It runs the same exact system image that runs on a device. So there are no surprises for you as an application developer when you move from developing within the emulator to actually debugging, say, on the device. Because the emulator runs the same exact system image or system image code, the toolchain for working with an emulator or working with a device is exactly the same. And in fact, it's seamless. And most of the tools don't even know which one they're working with, whether it's an emulator or a device. So the team, we've developed a set of command line tools that do a variety of different things. So compiling, converting your code into DEX, bytecode, packaging all of these things up and creating an APK. But what we also wanted to do was provide a nice front end because for some people it's much easier if you can have a graphical interface. So to do that, what we've developed is the Android Eclipse plugin, and it's a front end for all of our command line tools, and it makes it very nice and easy to create your own projects, debug them, develop them, and also deploy them. And so to show you that much of the development is almost exactly the same as you would for say a Java program. This is a picture of doing debugging within Eclipse. You can see you have your call stack, you can set your breakpoints in single step through a variety through your code. And you can also see your variables in terms of where you are. So that's, there's the standard experience in terms of debugging a Java application. But what we've also developed are some custom tools. One of them is TraceView, and this is used for figuring out, where's all the execution time going in your application, and how do you make it perform better. So when you instrument your code through TraceView, what you'll be able to see are things like the graphical timeline up on the upper left that shows you, okay, well, where's the execution time being spent? On the right, there's your call stack, and also kind of threads and other work that's going down below. So that's just an idea of the tool chain. And what I think is important to understand about Android and why it's different from other platforms is to ask the question, what do we mean by when we say it's an open platform? Because it's not just open source, which it is, but it's also an open platform. And I think this is the biggest differentiation for Android as a mobile platform. So when we say open, we mean a couple different things. And the way to look at it is from the perspective of the actors within kind of the mobile industry. So we'll go and we'll take a look at this, and I'll talk through each of those. So the first is industry. And when I say industry, I mean manufacturers, operators, commercialization partners, companies who are putting together devices benefit from Android being an open platform in a couple of different ways. The biggest, of course, is that the software is provided for free. The Android code, the Android platform will be open sourced under the Apache 2 license. Of course, our work in the Linux kernel and on things like the Eclipse plugin are governed under different licenses. So we've released those changes already. But we will make all of the code that I showed you in the stack diagram, everything from the Linux kernel above, available for free under the Apache 2 license after the first device is shipped. And why after the first devices? Because, quite frankly, we're not done with it yet. And with that code, anybody, whether it's a manufacturer or even a hobbyist, can take that and build a system image. And if they can find compatible hardware, or if they can port the platform to specific hardware, they'll be able to install that and install Android. So next in this triangle is users. And when we talk about open for end users, really there are a couple of important things. The first, and the biggest and overriding principle that we've been working with as we've developed the platform is that end users are in control of their experience. And that manifests itself in a couple different ways on the platform. The first is that users get to control what gets installed. So no one gets to tell an end user that, no, you can't install this particular application. And so they can go anywhere they want to get an Android application, they can install it. But it also means that they can choose the defaults. So let's say you don't like the default mail application that comes on the device that you have. If you want to go and grab a different mail application, you can install that and set that to be your default application if that's what you want. And last but not least, and I think this is the most important part, is developers. And for developers, when we say Android is open, there's a couple of different things. First and foremost is that as a developer, you don't need to get permission to ship an application. Just like on the web, where you don't need to ask anyone's permission to put up a website and make your service available. We want that similar sort of openness for developers to be able to innovate in mobile, which is why we're making Android a platform where you as developers don't have to get your application certified. Also, like I mentioned earlier, there are no hidden or privileged APIs. So the home screen, the phone dialer, the contacts application, all of these things work with the same APIs that are available to you as developers. And so you're able to, if you want, even create applications that can supersede or replace those applications. And that gets in, so those are kind of two ways that Android is open from a policy perspective. From a technical standpoint, the way that Android is open for you as developers, it really breaks down into three key concepts. And the way I like to summarize them is that you can, as developers, you can integrate, extend, and replace existing components. And I'll show an example of what each of those might look like. So integrate. When I say you can integrate with existing components, think of it as integrating with an application that's already on the device. So let's say, and the example I'm going to show here is the browser. The browser, actually, what I've done is I've searched for the address for Google's headquarters in Mountain View. And the search results have returned a one box, and I've clicked on the address. And normally, if you do this from a desktop browser, it takes you to maps.google.com, Google Maps. And that's pretty straightforward. We could do that in the browser. But one other thing we've done is we've developed a specific Maps application. And what you're seeing up here on the screenshot is the browser, the system offering me as a user the option to pick, well, do we load this link in the browser and show it like you might see on a desktop browser, or do we start the Maps application? And I'm going to choose the Maps application, so of course I'll see what you would expect from Google Maps in terms of that particular location. And the point I'm trying to illustrate here is that Maps and the browser are two separate applications, and the browser is able to start the map, this particular view in the map, and show that to the end user by making a generic request to the system to view a location. And the system has found that the Maps application is the best thing that can serve that up. And so in that way, by using what we call a system of intents, things that your application wants to do, you're able to integrate with existing components without having to know too much about, say, a specific API. So the next concept was extend, and this is, I think, fairly straightforward. The app that I've put up there is a screenshot from an application called Call a Cab. It's one of our top 50 applications from the Android Developer Challenge. And the application that they've written actually leverages an existing component on the platform. It's actually what we call a map view. And they've taken that and extended it, and they've put their own custom widgets and a custom UI on top of it, so that it's easier for an end user to be able to call a cab. And so the point I'm trying to illustrate here really is that for existing components and also libraries that other applications might provide, you can take those and you can extend them with custom logic to make them yours, so that in a way that you want to use them within your own application. The third concept was replace. So this is also fairly straightforward. The screenshot up there is a screenshot of the contacts application that comes by default in the platform. It's fairly straightforward. It's a kind of a dry contacts application. Let's say you kind of didn't like that, or you thought you could do better as a developer. And somebody actually did think that. We have another application up here. It's called Phonebook 2.0. It's another one of our Android Developer Challenge winners, or top 50. And they wrote a replacement for the contacts application. So because the platform is open, and because end users can install and also even set this application as, say, the default phone book that they want to use, a scenario like this can play out, where let's say I'm in the browser or in some other application and I want to save this particular phone number to my contacts. Well, even though the browser application was developed without any knowledge of this Phonebook 2.0 application, When I hit that Add to Contacts button that's orange up on the screen, it would go into the phone book 2.0 as opposed to going into the default contacts application. So for you as developers, there's an ample opportunity to even do better than the applications that get provided in the platform. And so if you have things, if you have ideas or things that can do better than existing components or other applications that come out, your users have a way to access that functionality. And so you should definitely try and take advantage of that. So I've talked a bunch about, the platform is open, and it's open for the industry and for users and for developers. But a question that always comes up is, what about security? How do you keep bad things from happening and keep the user in charge of the phone? At a very basic level, in the runtime environment, every application runs in its own process with its own unique user ID. And there's really no exceptions in terms of giving a unique user ID to an application. The only 3 exceptions in the system currently are for the init process in Linux. There's also what we call the Zygote process, which I think Ben will talk a little bit more about, but it's related to Dalvik. And then there's the main runtime. So those are the only 3 processes that run on the system that share a user ID. In addition to that, because applications are siloed into their own process, the only application that can get access to the data that your application has created is your own. So there's no way that another application could get access to, say, the photos that your application has stored on the device, unless you want them to, because we also have a system of permissions and also APIs, things like the content provider, where you can explicitly share and expose the data that your application is generating with other applications. So in that way, I think we make it easy for you to share, but also make it hard for you to inadvertently share your application's data with other applications. In addition to that, there's also a system of permissions, or a series of permissions that your applications have to declare if you want to use certain things. So there's things like making phone calls, or sending SMS, or getting access to the contacts app, the contacts database. All of these things are protected by a series of permissions, and all your application has to do is request that permission in the manifest to say, this application wants to be able to make phone calls, and also send SMS and access the phone book. And what we do with that information is at install time. So when the user installs your application, we show them, okay, well, these are the permissions that your application wants to use. And if an application is asking for all 3 of those things or other permissions, and all you've downloaded is a game, it might be kind of fishy, right? You wouldn't want to install a game that wants to make phone calls behind your back. So in that way, our philosophy for keeping the user in charge of their experience is to inform them what the applications will do, so that there's a minimal amount of friction when installing an application. Because really what we've seen, I think, when we looked at other platforms, there are instances where every time an application does a particular activity, it shows a warning to the user, which makes the end user experience kind of undesirable in terms of being able to actually successfully use that particular app. So to sum this all up, because I'm starting to run out of time here, what does this all mean for developers? It means a couple of different things. First, you develop your applications using the Java programming language, using tools that, if you're familiar with Java, you should be familiar with. You can leverage things like Eclipse. I know that there are IDE or plugins being developed for NetBeans as well as IntelliJ. You also get access to a rich and coherent set of APIs and system services for building your applications. So you can get access to things like location, 2D, 3D graphics, audio, video, all of these things that are something that are, what we think you as developers could use to create great applications, things that, we haven't even thought about as, we're developing the platform. So that's it for talking about what is Android. Now what I want to do is catch you all up on the latest news, where have we been and where are we going. So this is a brief timeline in terms of what we've done. The first thing was back in November of last year, we announced Android and the Open Handset Alliance. We released the first early look at our SDK. And we call it an early look because really we're not done with it. It's not what we are calling, or it's not a 1.0 release yet. So we're calling it an early look and hope that you as developers can bear with us as we make changes and improve things. But we're also giving it out as an early look because we want your feedback to better understand, okay, well, how can we make things better for you as developers to be able to build applications. And then in early January, what we did, we opened or started taking submissions for the Android Developer Challenge. And in February, we released an updated SDK, and that's the current SDK that's available today, what we call M5. And in April, the deadline was mid-April was the deadline for the Android Developer Challenge. And we were blown away by the number and the quality of the applications that we got. We got almost 1,800 applications from over, I think, 70 different countries around the world. So there were many, many applications. We had about 100 judges participate in judging these applications from around the world. And in the middle of May, we announced the top 50. So what are we doing with this Android Developer Challenge? Well, in short, our goal with the challenge is really to help you as developers turn whatever great ideas you have into great code. And to do that, what we're doing is we're running a series of 2 challenges, Android Developer Challenge 1 and 2. And for each, we're giving away $5 million. So the top 50 from Android Developer Challenge 1 have already gotten, I think, 1.25 million spread over the top 50. And then we're giving away the rest, the remaining almost 3.75 million to the top 20 applications after they've had a chance to refine their work. So if you missed out on Challenge 1, don't despair. There's going to be Android Developer Challenge Part 2, and that will be sometime after the first device is available. And device availability, since everyone asks this question, the first devices that are powered by Android will be available on the market in the second half of this year. So one of the things I always like to point out are online resources. We have a variety of different things available from that URL. It's on code.google.com. And you can find our documentation, you can find links to download our SDK, and also links to our groups where a lot of developers from around the world are collaborating and asking questions and even answering other questions. So if you're looking for a place to ask questions and find out more about Android, our groups are definitely a place to go. And of course, people from Google are participating in that as well to answer questions and clarify issues where things come up. So with that, I want to end my presentation and open things up for Q&A. So I think we have mics, so if you raise your hand, we'll come over and happy to take your question. Anybody?
Do you have any antivirus protection methodology? For example, you say that user can free download any program to his smartphone. So if I'm a hacker, I will implant the virus. So how do you to protect user from the infection?
Sure. Well, it really starts, from the process level on up, right? So, like I mentioned earlier, every Android application runs in its own system process, and so that, to a large extent, sandboxes the application from doing anything. The other thing is that, let's say that application, locks up the screen or doesn't allow the user to take control of their device again. Well, one of the things I didn't get into too much today is that Android applications are the life cycle of your application is managed by the system. So the system starts up and tells you, and stops and kills applications as needed. And part of that is, because we're running on an embedded device with a limited amount of memory. So we need to manage the life cycle. Well, if we detect that an application is, keeping a user from using the phone further, we can show one of the things is the activity manager can detect that and let the user actually kill that application. So that's one way. I think because we're building a platform, we're not specifically building, say, an antivirus application. But that's an opportunity for third parties if they feel as though there's a market for this to develop applications for that. But we think that with our approach in terms of sandboxing applications from the process level and also the system of permissions where things that would be especially malicious for an end user are protected and actually made explicit when they install the application, that we can strike a balance.
How fast is the actual Android devices? Because we don't have a chance of using them, right? So how fast are they, and especially the OpenGLES?
So I think you had a couple different questions. How fast are devices, and what's the OpenGLES implementation look like?
Because when I run emulator on my computer, it's not really that quick.
Right. Well, I mean, the thing to keep in mind with the emulator is it's emulating, an ARM instruction set, so it is going to be slower. The emulator in M5 is actually slow. We've noticed that it's slow too, and in our development since we've released that, we've actually sped up the emulator a little bit. The OpenGLES implementation, where devices support it, because remember, Android's a platform, so it can run on many different devices. If the device has 3D hardware acceleration, so if there's a chip in there that will do acceleration, the platform can take advantage of that. So if you're on a device that has like a chipset where there's 3D hardware, we'll take advantage of that to do the OpenGL operations. Again, your other question was about how fast are the devices. I think because Android runs on a variety of different devices, it's a platform. It's hard for me to say, okay, well, how fast is one device going to be versus another? Largely because it's up to the manufacturers in putting together those devices. But to give you an idea of, say, the minimum system requirements, Android, the minimum system requirements are currently a 200 megahertz ARM9 app processor, 64 megs of RAM, and 64 megs of flash. And so that puts you at about a smartphone from about 2 or 3 years ago. So that's bare minimum requirements, obviously. So as far as how fast a specific device runs, it really depends on the device.
So the devices you see, is the animation smooth?
Of course. So his question was, on the devices that we're working with and some of the reference devices, are the animations smooth? And the answer is yes, definitely. If you take a look on YouTube, what we've done is we did a demo at Google I/O, which was 2 weeks ago, and we actually demoed a device. And I think it was Steve Horowitz, who's our engineering director. So if you take a look at that, you'll see just how smoothly that particular device is in terms of drawing to the screen, doing things, drawing, running different applications. So.
I have two questions. The first question is about the bandwidth. Can you estimate the necessary bandwidth for your application? Bandwidth. When you implement an application, can you estimate the necessary bandwidth when you're running?
Okay, so your two questions were about battery and bandwidth?
No, the first question is about bandwidth.
Bandwidth, okay.
Okay, the second question is about is it possible for the third party input new driver on the Android platform? For example, in the platform we can see the Bluetooth and USB, and maybe there may be somebody implement WiMAX on that platform. Can third party implement this on this Android platform?
Okay, let me take those in reverse order. So for third parties, right now all that's available is the SDK. Excuse me. And that's really meant for application development. So that's not going to enable you to, say, insert a driver into the kernel layer or the hardware abstraction layer. But because the platform is going to be open source, once all the code is available, a third party could take it and create a WiMAX, driver for a WiMAX chipset or whatever else they want to do with it. So from that level, from the hardware level, really the code has to be open source before you can really do anything with it. But once it is, we expect a lot of people to take it and do all sorts of hopefully amazing things. Your other question was about estimating bandwidth. Well, one of the ways you can do that is in the emulator you can actually throttle and simulate what sort of radio speed you have. So whether it's Wi-Fi or if it's GPRS or Edge or 3G. So there's a bunch of different settings. If you can do it from the command line, if you want to start the emulator from the command line, or you can do it from within the Eclipse plugin, from a graphical screen where you can toggle things like network speed and latency as well.
What is the difference between OHA member and non-OHA member?
So your question was about what is the difference between an OHA member and a non-OHA member? Well, the members of the OHA have joined together to build Android and bring it to the market. And the various groups the 5 different groups that I showed you are providing different commitments. So like an operator, the operators that are up on the screen are committed to deploying Android devices. Likewise with, say, or differently, like say with the software vendors. Those software vendors are providing software that goes into the platform. So one of the companies that was up there was Packet Video. Packet Video is providing the media codec framework for the Android platform, and that will be open source. So really, right now, I think the difference. So that's what being in the OHA means, and I think that's how I can answer the question.
Yeah, but what kind of open source can be accessed by different parties like OHA members?
So once the platform is open sourced, everyone has access to the same code, right? Because we're going to open source all of it. Everything will be available as for free for anybody who's whether you're an OHA member or not. Like if you wanted to take it and take all the coding and build a different system, you could certainly do that. And in terms of the Apache license, lets you take it if you want to modify it in some sort of way. You can do that, and if you want to keep those changes, you certainly can.
I'm not quite clear with the permission schema. Can you explain more? On Windows Mobile device or Symbian, we have certification which signed application have higher privilege.
Right.
And on Linux-like system, we have sudo command, which we can do that.
Sure.
And Android.
So on Android, when we talk about permission, when we talk about application permissions or system permissions, what you have to do is, from your application, let's say you're writing an application that helps you find pizza parlors that are around you, and you want to make it easy for your user to just call that pizza place directly from within your app. Well, in order to make calls directly, because we don't want every app to just make calls willy-nilly willy-nilly. What you have to do is you have to request the permission to make phone calls. And that goes into a manifest file that's bundled with your application. So the manifest is just metadata that you include with your file or with your application. And what we do with that information is we show that to the end user. So when they install this pizza parlor application, they'll get shown that, this application wants to be able to make phone calls. And that way, are you sure you still want to install this application? And so, like you pointed out, some other platforms have certification where, certain applications get a higher privilege. From our perspective, we think that an open platform, one that doesn't involve certification, actually allows for more innovation. Allows you as a developer to make your applications and make them available to end users faster and easier, and be much more creative about what you can do in your application. So that's that's a high-level kind of overview of like how those permissions work and why they're there. Does that answer your question?
I want to ask about the capability in the future because the manufacturer and the operator like their specific feature. So how can we make sure our AP can run the most accurate?
Okay, so your question is about how can you as a developer ensure that your application can run on the most number of devices, right? So there's a couple different things, but the biggest is to make sure that you are using the APIs that are available in the standard platform. And where operators and manufacturers implement a true Android device, your application will run. The thing to keep in mind though is that some devices will be HVGA, some of them might be a different screen size. So there might be some work for you to do as devices come to market that have different screen sizes to do some work to make sure that it looks good on at those screen sizes. But I think that's going to be one of the places where you'll do some work. And you can simulate that right now with the emulator, because the emulator, even though it starts up in HVGA, you can resize it to be QVGA or some full VGA or what have you. So if you want to see kind of what your app looks like at various screen sizes, you can do that. The other thing is that the app framework provides a set of widgets and layouts for creating your GUI. And if you stay away, as long as you use the layouts that are not absolute, so there's an absolute layout where you tell the system, put this and this at X and Y coordinate. As long as you don't do that and use just the relative layout tools, the framework can actually resize and reflow your screen for various screen sizes. I didn't include it in my presentation, but the things we did was we wrote a calendar application and I forget what the other one was, a contacts application. And then we ran the emulator in a variety of different screen sizes. And because we didn't use the absolute positioning, the framework was able to actually resize all of the UI and make it look actually pretty good on all the different screen sizes we tried. So I think that's the biggest place where you'll do work to make sure that your app can run across as many devices as possible.
Since we have a couple web-based applications running well on top of the internet base,
Okay.
so do I need to make some change in order to run into your Android? Since you do mention the browser application,
right?
So does not fully compatible with such as the IE browser 6 point something. I mean edges or DOM, whatever issue, I will overcome something.
Okay. So your question is about, what do you as a web developer have to do to be work with Android insets? Well, the good news is it's probably not very much. The Android platform comes with a browser that's based on WebKit. And WebKit powers Safari. It also powers the browser on the iPhone. So you have a full browser that supports JavaScript, DOM, all the things that you would expect in a browser on a mobile device. So, and it's a full desktop-style browsing paradigm. So if you, again, I don't have a device to demo here, but what you should really take a look at is the video that we showed, the demo that we showed at Google I/O. Steve actually demos the browser and shows how you can zoom and these sorts of things and flip the screen and move around. So if your website actually renders well within WebKit, say like on Safari or even the iPhone browser, I think that your website will actually, you won't have to do too much to work with the Android browser.
So, when can we expect the first version device available in the world? I mean, along with your Android. We are very aesthetic.
I get this question a lot, and unfortunately the only thing I can say is sometime before the end of the year. Second half of 2008 is what we're saying. So, but if you want to test things now, if you download the SDK, the emulator has a browser application in it. So you can, and that browser application will use your laptop or your computer's network connection, and you'll be able to go and surf to your website and make sure that it looks okay. So I think I've been told I have time for one more. Is that it?
Yeah.
Okay, so I have time for one more question. Right over there.
Will developers be able to change the libc or OpenGL library in the Android system?
So your question was about whether developers will be able to change libc or the OpenGL implementation in the system. So if you're thinking of doing that, say from simply the application SDK, you can't do that, right? Because the SDK is really meant for application development. But once we open source, all the code is going to be available. You could take that code and do things, do whatever you want with it because we're licensing it under the Apache 2 license. Now, I would have questions as to why you might want to replace them. One thing that I would point out is that libc that's in our system stack is actually something custom that we've done, and we call it Bionic. And it's, doesn't implement all of glibc, so you don't get certain methods or operations. So you'd have to, if you want to be compatible with the rest of the platform and stack, you'd really want to make sure that you took a look at what was already there. So, thank you. So with that, I think we're done. So thank you very much. I will stick around and be happy to take questions in person if you want to come up and ask me anything. So.